Welcome to Level 1. Think like a tester. Imagine this is your first day as a software tester at Phoenix Bank. Your team is preparing to launch a brand new internet banking platform that millions of customers will soon use. At first, you may think your job is simply to click buttons and report bugs, but your mentor quickly tells you something different. Anyone can execute test cases. Professional testers protect customers, reduce business risks, and build confidence before every release. Throughout this course, you'll learn to see software the way experienced testers do, and that mindset will become your greatest professional advantage. Before we start, let's look at the journey ahead. Think of becoming a quality engineer like constructing a building. Without a strong foundation, the tallest structure will eventually collapse. In Part 1, you'll develop the mindset and observation skills that distinguish professional testers. In Part 2, you'll learn how experienced testers organize their work, communicate with teams, and follow professional testing workflows. Finally, in Part 3, you'll expand beyond testing to understand quality engineering and practice everything you've learned in realistic workshops. By the end of Level 1, you'll have the same thinking framework used by professional QA teams worldwide. Every great journey begins with understanding why it matters. Today, we'll complete 2 connected modules. First, we'll answer an important question. Why does software need testing? You'll discover that testing isn't about finding bugs. It's about protecting customers and reducing business risks. Then we'll explore how testers observe software. You'll learn why a developer, a customer, and a tester can all look at the same screen yet notice completely different things. These 2 modules will change the way you think before they change the way you test, creating the mindset you'll continue developing throughout the next 2 parts of this course. Emma, your QA lead, asks a simple question on your first day. Would you transfer your entire salary through an application that crashes once every 20 transactions? Everyone immediately answers, of course not. She smiles and says, that's exactly why software testing exists. Customers don't care how many technologies a company uses or how many developers built the system. They care about one thing: whether the software works reliably when it matters most. In this module, we'll discover why quality directly affects trust, reputation, and business success, and why testers play such an important role in protecting all 3. Let's compare 2 customer experiences. Sarah orders dinner through a food delivery app. Everything works perfectly. Payment succeeds, the restaurant receives the order, and her meal arrives on time. She happily uses the app again. Now imagine another customer whose payment is deducted, but no order appears. The support team cannot explain what happened. Which customer is more likely to recommend the application? Users rarely remember every feature, but they always remember whether the software was reliable. Every successful interaction builds trust, while every failure destroys it. That's why quality is a business issue, not just a technical one. Now let's return to our Phoenix Bank project. A customer transfers $10,000 to purchase a new car. The application suddenly freezes after the transfer button is pressed. The sender's balance decreases, but the receiver never gets the money. Within minutes, customer service receives hundreds of calls. Social media fills with complaints. News websites begin reporting that the bank has payment problems. What started as a single software defect has become a business crisis. Professional testers don't simply ask, can this feature fail? They ask, what happens to customers and the business if it does? That perspective changes everything. Banking is only one example. Every day, software controls hospitals, transportation systems, online shopping, manufacturing, education, and even the smart devices in our homes. Imagine an ambulance navigation system calculating the wrong route, or an airport baggage system assigning luggage to the wrong flight. The consequences extend far beyond inconvenience. Software now supports almost every modern business process, meaning quality directly affects people's daily lives. As software becomes increasingly important, the responsibility of testers grows as well. Every feature you verify may eventually influence thousands, or even millions, of real users. Think of software quality as the foundation of a pyramid. At the bottom is reliable software. Reliable software keeps business operations running smoothly. Stable operations generate revenue. Healthy revenue strengthens the company's reputation, and a strong reputation earns customer trust. Remove the foundation, and everything above begins to collapse. This explains why executives invest heavily in software quality. Testing isn't performed simply because developers might make mistakes. Testing exists because every successful release protects customer confidence, supports business growth, and reduces costly operational risks before they reach production. Emma shares a real lesson from an earlier project. A tiny validation bug allowed duplicate payment requests whenever users clicked the payment button twice during a slow network connection. Developers fixed the defect in less than 2 hours. Recovering customer trust, however, required several months. The company refunded transactions, handled media questions, increased customer support staffing, and launched communication campaigns. The code change was small, but the business impact was enormous. This is why experienced testers always evaluate risk instead of simply counting bugs. Sometimes, one carefully prevented defect saves far more money than fixing hundreds of small cosmetic issues later. Many beginners believe bugs appear only because developers write incorrect code. In reality, defects can be introduced long before programming begins. A business analyst may misunderstand customer needs. Designers might create confusing workflows. APIs can exchange incorrect data. Configuration differences between environments may cause unexpected failures. Infrastructure problems can also affect perfectly written software. Think of software development as a relay race. Every team passes work to the next. If mistakes occur at any stage, they can eventually appear as production defects. That's why professional testers observe the entire development lifecycle, not just the finished application. The next morning, Emma invites you to sit beside a senior developer named David. After demonstrating the new login feature, David confidently says, "I've tested everything. It works perfectly." Emma smiles and asks, "Did you try entering a 300-character password? Did you disconnect the network halfway through? What if someone clicks login 20 times? David laughs because he hadn't considered those situations. This is the difference between developers and testers. Developers focus on building the solution correctly. Testers focus on discovering situations where the solution might fail. Different perspectives create stronger software. Let's compare two conversations about the same feature. David says, "The transfer function meets the requirements." Emma asks, "What happens if two transfers arrive at exactly the same millisecond? What if the customer refreshes the page? What if the API responds twice?" Neither person is wrong. They simply think differently. Developers naturally focus on creating successful outcomes, while testers deliberately challenge assumptions and explore uncertainty. Professional testing isn't about distrusting developers. It's about providing a different viewpoint that helps the entire team deliver software customers can rely on. During your first sprint, you expect most of your day will involve executing test cases. Instead, you notice Emma spends surprisingly little time clicking through the application. She begins by reviewing requirements, discussing business rules with the product owner, asking questions, identifying risks, preparing test data, and designing scenarios before any execution begins. Only then does testing start. Afterwards, she reports findings, verifies fixes, and suggests improvements for future releases. You quickly realize that testing isn't an activity performed after development. It is a continuous thinking process that begins long before the software is ready. At the sprint review, the team celebrates because only one minor typo was found before release. As a new tester, you're disappointed. You expected to discover dozens of bugs. Emma explains, "Finding fewer bugs isn't failure if we prevented bigger problems earlier." During requirement reviews, the team had already clarified ambiguous business rules and removed several high-risk defects before development even started. The real purpose of testing isn't collecting bug reports. It's reducing uncertainty, managing risk, and giving stakeholders enough confidence to decide whether the product is ready for customers. Later that week, you join a planning meeting. The product owner explains customer needs. The business analyst clarifies business rules. Designers present the user journey. Developers discuss implementation. DevOps prepares deployment. Customer support shares issues reported by existing users. Emma listens carefully to everyone before proposing test scenarios. You suddenly understand something important. Software quality isn't created by one department. Every role contributes a different piece of the puzzle. The tester becomes the connector who brings these perspectives together and ensures the entire team works toward delivering a reliable product. Before leaving the meeting, Emma shares her own career story. She started as a manual tester, writing test cases and reporting bugs. Over the years, she learned SQL to validate databases, APIs to understand integrations, automation to improve efficiency, business analysis to understand customer needs, and AI tools to accelerate testing activities. Today, she spends more time solving quality problems than executing repetitive tests. Modern testers are no longer defined by the number of test cases they execute. They're valued for how effectively they improve product quality across the entire development lifecycle. Emma sketches your future career on a whiteboard. Today, you're a beginner, she says. Soon you'll become a tester who understands business risks. After that, you'll learn agile practices, automation, quality engineering, AI-assisted testing, and eventually leadership. She reminds you that every expert once started exactly where you are today. Technologies will continue evolving, but curiosity, critical thinking, communication, and structured problem-solving remain timeless skills. This course isn't designed to make you memorize testing techniques. It's designed to build a mindset that will support your entire career. Let's pause and reflect on everything we've learned so far. Software quality directly affects customer trust, business reputation, operational stability, and revenue. Bugs can originate anywhere, from requirements to infrastructure, not only from code. Testing is fundamentally about reducing risk rather than proving perfection. Developers and testers contribute different perspectives toward the same objective. Most importantly, quality belongs to the entire team, not only QA. These ideas form the foundation of professional testing, and they'll guide every decision you make throughout the rest of this learning journey. Now that you understand why testing matters, Emma gives you your next challenge. She opens the login page and asks, "Tell me everything you see." After a few seconds, you answer, "Username field, password field, and a login button." Emma smiles and replies, "That's what everyone sees. Now tell me everything you don't see." At that moment, you realize professional observation goes far beyond the interface. Hidden behind every screen are business goals, assumptions, security concerns, integrations, and risks. In this module, you'll learn to observe software the way experienced testers do. Emma points to the login screen projected on the wall. Most beginners verify that valid credentials successfully reach the dashboard and stop there, she explains. Professional testers begin asking questions. Can someone paste a 10,000-character password? What if the browser refreshes during authentication? Can SQL injection be attempted? Does repeated clicking create duplicate requests? Is sensitive information exposed in error messages? The screen hasn't changed, but your perspective has. Great testers don't simply interact with software. They investigate it, challenge it, and search for hidden risks that ordinary users and developers might never notice. Emma gives you a simple assignment. Spend 5 minutes studying this login page without touching anything. At first, it feels easy, but as the minutes pass, you begin noticing details you missed before. The password requirements aren't explained. There's no forgot password link. Error messages may reveal account information, and there's no indication of session timeout. Emma explains that observation isn't just seeing what's on the screen. It's understanding what should be there, what shouldn't be there, and what hidden assumptions might affect the user's experience. Great testing always begins with careful observation. Emma asks everyone in the room the same question. What do you see? The product owner talks about customer convenience. The security engineer immediately worries about brute force attacks. The UX designer notices inconsistent button alignment. The developer checks API responses. The operations engineer thinks about server performance during peak hours. Each person observes the same feature, but through a different lens. As a tester, your advantage comes from combining all of these perspectives. The broader your viewpoint, the more risks you'll identify before they become production problems. You begin with the most obvious scenario. A registered customer enters a valid username and password, clicks login once, and reaches the dashboard within 2 seconds. Everything works exactly as intended. This is called the happy path, the ideal journey where every condition is correct. Every feature should have a happy path, because it confirms the system can achieve its primary business objective. However, Emma reminds you that customers don't always behave ideally. Professional testing starts with the happy path, but never ends there. Emma now changes only one condition. Instead of using a password, the customer chooses biometric authentication on a mobile device. Another customer logs in using single sign-on through the corporate identity provider. A third user receives a one-time password before access is granted. All these scenarios still achieve the same business goal, successful login, but through different routes. These are alternative paths. Real applications usually support multiple valid workflows, and every one of them deserves testing because customers rarely use software in exactly the same way. Now Emma deliberately breaks the normal flow. The customer enters an incorrect password 5 times. The internet connection drops halfway through authentication. The authentication service becomes unavailable. The session expires while logging in. Suddenly, the application behaves very differently. These are exception paths, situations where something unexpected happens. Excellent software doesn't simply succeed under perfect conditions. It also fails gracefully, protects user data, provides meaningful guidance, and recovers whenever possible. Many of the most critical production defects appear in these exceptional situations, rather than the happy path. The login feature now works correctly from a functional perspective, but Emma isn't finished. She asks, how quickly does it respond when 10,000 users log in simultaneously? Is the interface usable for visually impaired users? Can attackers bypass authentication? Will it work on different browsers? These questions introduce another important idea. Quality isn't only about whether a feature works. It's also about performance, security, usability, accessibility, compatibility, reliability, and many other characteristics that influence the overall customer experience. Instead of immediately writing test cases, Emma fills an entire whiteboard with questions. What assumptions does this feature make? What inputs are accepted? What happens when external systems fail? Which users are affected most if this feature breaks? What business rules are hidden behind the interface? You notice something interesting. Experienced testers often spend more time asking questions than executing tests. Better questions uncover hidden risks, clarify ambiguous requirements, and prevent expensive defects before development is even completed. As you become more comfortable with testing, Emma gives you one final challenge. Forget the requirements for a moment, she says. Explore. You try copying and pasting unusual characters, refreshing the browser repeatedly, resizing the window, switching languages, using expired links, and opening multiple browser tabs simultaneously. Most actions weren't listed in any requirement document, yet several unexpected behaviors appear. Curiosity is one of the greatest strengths of a professional tester. The willingness to explore often reveals risks that structured test cases alone might never uncover. By the end of your first sprint, you notice your thinking has changed. You no longer ask only, does it work? Instead, you naturally ask, who could be affected? Under what conditions could this fail? What assumptions are we making? What risks matter most? This shift is what separates professional testers from people who simply execute checklists. Tools, automation, and I will continue evolving, but critical thinking, structured observation, curiosity, and risk awareness remain the foundation of effective software testing throughout your career. Let's summarize what you've learned in this module. Professional observation means looking beyond what's immediately visible. Testers evaluate software through multiple perspectives, explore happy paths, alternative paths, and exception paths, and consider both functional and non-functional quality attributes. Rather than jumping directly into execution, experienced testers ask thoughtful questions and investigate hidden assumptions. Most importantly, you've started developing the mindset of seeing software as a collection of potential risks, instead of simply a collection of screens. That's exactly how professional testers think. At the end of your first week, Emma gives you one final exercise. She opens the banking application and says, forget you're a tester for a moment. Imagine you're a bug trying to escape into production. Where would you hide? Suddenly, you begin looking at the software differently. You notice complex business rules, integrations with external systems, unexpected user behaviors, and edge cases that previously seemed unimportant. That's the mindset of a bug hunter. Great testers don't wait for problems to appear. They actively search for the places where problems are most likely to exist. Emma shows you a defect reported by a customer. At first glance, it looks like a simple login error. But after investigating, the team discovers the real cause was an incorrect requirement written months earlier. Another defect turns out to be caused by an outdated API specification. A third originates from inconsistent test data. Emma explains that every bug has a story, and understanding that story helps prevent similar defects in the future. Professional testers don't just report defects, they learn from them and continuously improve the entire delivery process. As the sprint comes to an end, Emma congratulates you. You've learned to observe software differently, she says, but observation alone won't make you a professional tester. The next step is learning how experienced QA engineers transform their thinking into a structured testing process. Planning, designing effective test cases, executing efficiently, reporting clearly, and continuously improving quality. Every expert tester follows a systematic approach, and that's exactly what you'll begin learning in the next part of this course. Before moving forward, let's reflect on the most important lessons from Part 1. Software quality affects people, businesses, and society. Testing is about reducing risk, not proving perfection. Great testers think differently from ordinary users by questioning assumptions, exploring multiple scenarios, and staying curious about how software might fail. Quality is everyone's responsibility, but testers play a unique role by helping the team discover risks early. Most importantly, you've taken the first step toward developing the mindset that every successful software tester shares. Congratulations on completing the first part of your software testing journey. Today, you've built the foundation every professional tester needs: the ability to think critically, observe carefully, and approach software with curiosity instead of assumptions. In Part 2, we'll build on this mindset and learn the practical workflow used by professional QA teams, from understanding requirements to designing effective test cases, executing tests, and communicating quality with confidence. Thank you for learning with us, and I'll see you in the next chapter of your journey to becoming a professional software tester.